Next, we will find the derivative of the natural logarithmic function. Let's recall the limit definition of the derivative of a function. And let's set f of x to be the natural logarithmic function. Then, according to the definition, the derivative will be equal to the following limit. Using the properties of the logarithms, we combine the logarithms in the numerator and then factor out x in the denominator. Since the variable of the limit is h, we treat x as a constant, and therefore we can take it completely outside of the limit. In what's left, we should recognize the special limit, which is equal to 1, and therefore the entire limit is equal to 1 over x. So the derivative of the natural logarithmic function is the reciprocal function. We now can add this fact to our table of derivatives. However, since the natural logarithmic function is only defined for positive inputs, we add a remark that its derivative is the reciprocal function only on the domain restricted to positive values. We found the derivative of the natural logarithmic function using the limit definition of the derivative of a function.